Okay, we're working on our DMR here. Can see you guys are on to at least numbers 2 or 3. Please continue to work. We'll just take another couple of moments here to try to wrap this one up.
My calculator was busy.
Others are not quite there. Let me show you the answers for this DMR.
Oh, I didn't completely.
Be happy to review any of these with you. How do you get a positive what? Or, it's negative. Sorry. I think I erased it should be negative 16/15, I think. Sorry. First one's negative 16/15. Either I forgot to write it or I erased it or something.
Number 1 and 2.
You do all of them? Yeah.
Oh, hold on. Let's let everybody get a chance to kind of grade. Guys, I don't know if we'll have time to do every single one of them. I just don't know if literally don't know if we'll have enough time to do all of them. I'm definitely going to do one because that's going to lead us right into our topic today, not number 2. Okay, y'all saw the answers there. Had a lot of folks say that they wanted to look at numbers 1 and 2 possibly. Okay, so here's number 1. So, number 1, did you guys notice that this second fraction is not really in the form that we like?
It's not in the form that
It's mixed numbers, right? So what do we want to do to this to get it in the form we like? Improper fraction. So 3/5 minus, what would that second fraction be as improper?
25th.
So the way you do it is you multiply the 1 times the 3 and then add the 2. So 1 times 3 is 3. Michael said it well. 3 plus 2 is 5. So 5 over 3 is that second fraction. So we do have different denominators, so we need to find the common denominator. What would that be, David?
You'd have to, you be quiet.
So Michael, if you would be quiet for a second, since I asked Davis. Davis, it is 15. How do you get that 15 though?
You multiply, so you take the 3 and you multiply by 3, and you take the 5 and you multiply by 3. And then
So hang on one second. I want to make sure I heard you right. So I need to take this 5 and do what to it?
Multiply by 3.
Okay, C.
And then times 3 on the top one too, the 3. And then you get 9/15.
9/15.
And then on the next one you would multiply by 5 from both. And then you would get 25/15.
Is this making sense? Good explanation of why and how. Okay, so when you are adding and subtracting fractions, what do you do with the denominators once they actually are the common denominator?
You just take the numerators.
What do you do with the denominators?
Oh, you leave it.
You leave it, yeah. So this would be something over 15. And what do you do with the numerators? You actually subtract or add or whatever you're supposed to do. So 9 minus 25 is negative 16. There's your final. So, Michael, you were extremely vocal about number 1. Do you have any follow-up questions on that one?
No.
Okay. Anybody else have a follow-up question on number 1? All right. So then number 2 is also asked for. So with number 2, number 1 is extremely old. Number 1 is from like 6th grade. And earlier this year too. We did those a little bit earlier this year too. Number 2 is much newer. It's from like, I don't know, a month and a half ago, something like that, 2 months ago. So if I've got radicals in here, I've got non-radicals in here, I'm going to multiply. Notice how I've got a 2x and a 3. Those are not radicals. And so you can multiply those just in the same way you've always multiplied them. What do you guys think 2x times 3 would be?
6x.
6x. And then, of course, notice that there's also some radicals in there. When you multiply radicals together, no, you actually just multiply them as normal. They just remain in a radical. So you would do 8 times 6, which is
24x.
48. And then x times x is x squared. So you'd end up with the square root of 48x squared. So please notice that to get this, I multiplied my 2 oranges together. To get this, I multiplied my 2 reds together. So you can multiply a radical times a radical, or you can multiply a non-radical times a non-radical. but you can't mix the two and multiply the way that you think you would. So the only thing remaining here is we need to try to simplify that root 48x squared. Anybody have any ideas on how that would simplify? Just the root 48x squared? Max, what do you think?
Wouldn't that be like, oh, the root 48, that would be 4x root, yeah.
I think you got an extra x in there. I think it'd just be 4x root 3. 4x root 3. Nice job, though. That's good with getting the 4x out of there. How did you get that? Like, what tool did you use to help you with that? Like, how'd you get the 4 out of there? Intelligence. You broke it down. Yeah. Broke it down into what?
8 and 6, and then kept going from there. It's like 2
And the 2s and the 3s, what kind of numbers are those? Got all that down to the prime factors. Perfect. Okay. So then the final step would be to recognize then that this is a non-radical factor. That's not a radical factor either. Those could be multiplied kind of like we did at the very start, right? So 24x squared root 3 would be your final expression there. Did anybody do this any differently? There'd be a slightly different way to do this. It's not that much different, but it could be better. Bless you. Okay. I don't want to complicate the matter. Okay, anybody want to talk about number 4? Did y'all see the 2, the common factor of 2 that can come out? Okay, that's really important that you get that 2 out of there first. How about number 3? Anybody want to do number 3? Oh.
Oh, y to the 8th? I got y. Wait, let me see what when it's so y to the 0, I just have a quick question.
Sure.
So if you have like y to the 8th and on the top, and then you have a y to the 0 on the bottom, does that just mean it's still y to the 8th?
Sure. So you could look at this in 2 different ways, I think.
Like subtraction.
If you're dividing bases, don't you leave the base the same and subtract the exponents?
Yeah.
So this would give me y to the 8 minus 0,
Yeah.
and 8 minus 0
It's 8.
is just 8.
Okay.
Another way to think about it,
Turn a 1 onto that.
another way to think about it would be this, and I think this is kind of what you were going for. So if you've got y to the 8 over y to the 0, as long as the y isn't 0, what's anything to the 0 power?
1.
1. So you could say this is y to the 8th over 1, and what's something divided by 1?
So
Itself. So y to the 8th divided by 1 is just y to the 8th.
I made the exponent a 1.
Oh, it doesn't make the exponent a 1. The exponent's a 0. But then the base to the 0 would give you a 1. Okay. Anybody else with a question, follow up, any details? Davis just asked kind of a little detail question there about the 0 power. Is anybody else with any kind of a question there? Okay. So let me just give you a brief outline of our week. Tomorrow, when we come to class, we will do a DMR. But then the very next thing we do after our DMR, our school year. This would be it.
yeah.
But can we still retake the concept quizzes before the test?
Yeah. Okay, so Michael asked about the concept quizzes. You guys basically have 2 weeks, roughly, 2 school weeks to get your concept quiz retries done. We still got the one concept quiz on graphing parabolas coming up this week. Tomorrow, I think. I think it's tomorrow.
21.
It's 21. It's 18 through 21. Yep. But then, the rest of it should just be hopefully really great retries. Have y'all figured out with the retries that if you don't really put in some significant effort leading up to the retry, you do the same or worse? I hope you figured that out. I am happy to be a part of that process. Like if you wanted to come to me and say, I've been studying this and I've been working on this and this, I still can't figure this one out. Can we talk about it? Of course, for sure. Let's just find a time to do that. Love to help you out. How about a little warm up? Will you guys try numbers 1 and 2, please? Numbers 1 and 2. Adding and subtracting the fractions. Of course. Okay, I'd like to hear your answers here. Mackenzie. Shh. Mackenzie, what'd you get for number 1? Could you guys say, Max? Mackenzie is like 9 feet from me, and I cannot hear her over you. Could you say that one more time, Mackenzie? 4/5. Right. What do you guys think of Mackenzie's answer there for number 1? Fantastic. Andrew, how would you get for number 2?
I got -1/24.
Okay, what do you guys think of Andrew's answer?
That's totally right there.
I got a thumbs up from Tyler. Quality work from Max. Michael got that too. So, to me, when I look at this, like if I didn't really know what I was doing, I would look at number 1, and I might be a little confused about the 5, but I would say, hey, 3 + 1 is 4. That makes sense. I would look at number 2, and I would say, I don't see any 1s anywhere. I don't see any 24s anywhere. That one might not make sense to someone who's struggling. Anybody want to explain why y'all agreed with Andrew's answer? What do you think, Luke?
Right.
Go ahead, Luke. Oops.
So the butterfly method, I think it's kind of fair. So the butterfly method.
Just tell me what you did.
So it's 8, you multiply 8 and 30,
So 3 times 8.
and then 3 times 8. And then you get 24 as the denominator.
Sure.
And then you also multiply the numerators by the same number.
I've never heard of that butterfly.
So basically.
Hey, one thing to bring out here, I think this would be really important for us to realize, especially today. And Luke has directed us correctly here. What's 3 divided by 3?
1.
So you realize all this is just a really strategic 1.
Yes.
What's 8 divided by 8?
1.
Same thing, right? So all we're really doing is we're multiplying one of the fractions by 1 and the other one by 1. But they're just really smart ones, right? They're not random. They're strategic. So 3 times 5 is 15. I think I would understand that. 3 times 8 is 24. So again, following Luke's lead here, 2 times 8 is 16. 3 times 8 is 24. And now, doesn't this look a lot like number 1?
It does.
So we would do the same thing. As was mentioned, 15 minus 16 is -1. -1/24. Shh. No, that's bogus. You can't divide by 0. It's really, it seems clever, but it's not that clever. Okay. Hey, guys, listen up. We're trying to lay some foundation. Like, this might seem really easy to you right now. Just wait. You'll be challenged. Guarantee it. Luke used a good term, I think, a second ago. He said the 24 that we got here and here, these 24s, is the, what did you say? What kind of denominator? No, it's not the butterfly. It's the common denominator. In fact, I would say we could add one more word onto that. We could say the 24 is the common denominator, but I think I would put one word at the start of that.
Most common denominator.
Lowest or least. Yeah. We're going to find that it's going to be relatively straightforward on how to find a common denominator, a little more challenging to find a least common denominator, and I think it's best for you, for sure, to find the least, the smallest common denominator. Good?
Yep.
Okay, so if you guys warmed up okay with those, I am hoping that a question like number 3 is something that you could explore with, and it looks very different, I get that. But let's see if you can take the idea that Luke threw out there and what you guys did with the 2 warm-up questions, see if you can combine, simplify these.
You can't.
Ready, go. I would love to hear if anybody thinks they know number 3. Max, what do you think,
I know
buddy?
the first step, I think.
Okay, what do you think we should do?
What we came together as is we think that the denominator is x plus 2.
Okay, so the denominator.
Had a kid.
That's all we know. That's all we know.
So let's stop and let's talk about that a little bit, Max, because that's worth talking about.
Okay.
So when you guys went back and you looked at this very start, and you look at your 2 denominators, Luke said in order to add these fractions, whatever they are, we need to have a common denominator. Are the x plus 2 and the x plus 2, are those the same denominator?
Yes.
Wait.
So as it currently stands, do we have a common denominator?
Yes.
Yes, we do. Okay. So remember before I said if you do have a common denominator, how does that show up in your answer? Like, what do you do with it?
Simplify, or no.
If you already have a common denominator,
You leave it.
leave it the same. Yeah, it just stays as is. So I would say, Max, based on that kind of reasoning,
Yeah.
wouldn't you agree that what you just said is correct?
Yes.
The denominator in our final answer should be x plus 2. Okay? So then what do you do with the numerators when you're actually adding the fractions up? What do you do with them, Max?
I just added them.
What you
But
get?
not added them. I was like, I got 4x plus 3.
Okay, well, that sounds like you're adding them to me.
Oh yeah, that's adding them.
Why couldn't we combine those and make them like 7x?
Because they're not like terms.
They're not like terms. Yeah. So what do you think? Is this it? Are we done with this one?
Can you
No.
cancel by like going top to bottom?
Oh, interesting.
There's just
You
one
could do like
in front
that.
of
It'd
it.
be like 3x plus 5.
Yeah, no, it's like 4x and then there's one
Interesting.
in front of the x on the denominator.
See what I mean, Tyler? So, I want to talk about this a little bit, but I want to overall give you an idea here that I think you should really grab a hold of, and it's this. I think probably the most misused tool in math is canceling. We love to cancel because things just like go away, don't they?
Yes, that's the point.
But it needs to be right, Max. We can't just like make things cancel because we want them to. They have to actually do this. So let's see here.
Isn't all math is just like making things cancel out until you get a right answer?
No, it needs to be reasonable. It needs to be logical. Let me present something to you. Let me present something to you. And some of you, I really hope you'll listen. Are any of you thinking that we should do this?
Yep.
I mean, they're right over the top of each other, right?
No, actually no.
So here is,
There's not a coefficient.
I would like to show you some reasoning here. Okay? I am so uninterested in just teaching. I'm so uninterested in just teaching you tricks because when you learn tricks, like I think maybe you probably did in middle school, which is kind of what I'm getting back from you right here, you don't know when to apply the trick. That's the thing. You just want to use the trick all the time. And canceling really is sort of a trick. So check this out. What if I wrote this? Would you guys agree with me that this is really similar to our answer in blue?
Yeah.
Haven't I just replaced the x's with 5s?
Hold up. Where'd you get the 5?
Yeah, where did you get?
So I want
He's
to
just doing an example.
be quiet. Please stop speaking. I would like to speak a whole sentence uninterrupted. Andrew, I'd like to answer your question. What I'm trying to show you is a numerical approach for understanding why you can't cancel. So do you see how I've created a very similar looking expression just with numbers instead of x's?
Yeah.
Okay. So if I follow order of operations, what would you guys say the numerator would be here?
23.
4 times 5 is 20, plus 3 is 23. What would the denominator be?
7.
So if I follow order of operations, follow PEMDAS, which I am extremely confident in, guys, I'm extremely confident in this. Do you guys agree with me that 23/7 should be the correct value?
Yes.
Now,
Wait, where'd you get the 5 though?
okay, everyone, do you see what happens when there's just random talking? Haven't I answered the same question? Isn't this going to be like time number 7 to answer the same question?
Yeah.
So everyone, do not speak. What I decided to do, please, I'm deadly serious about this. Don't speak. Please control your tongue. Michael, you said, where did the 5 come from? So I had a lot of people that said, hey, couldn't we just cancel the x's out? And I said, no. And they were like, no, I think you can. And so what I'm trying to prove to you is that you can't. And I'm doing this by using numbers. The x's are kind of hard to deal with, right?
I'm just confused, like where the 5 came
So, Michael, I'm getting there. I'm getting there, man. So listen to me. So Michael, do you see how I replaced my 2 x's with 5s? I'm doing this because it's easier for you to see numerically, right? You're going to be able to see how the numbers work out versus just the x's. I'm trying to give you something that's easier to understand.
Okay.
So do you see how the 5s are in place of the x?
Yeah.
So just stay with me here, okay? Guys, again, I asked you to not speak. Please obey. My job is to teach you. It should not be to referee your behavior. Get it? Please obey. It's a really simple instruction. So Michael, check this out, bud. Here we go. So we all in agreement that 23/7 is the correct value?
Yes.
So if I were to do what was suggested, it should work out to be the same if it's correct, right? So it was suggested that I cancel out the x's, so an equivalent would be to cancel out the 5s, right? Do you see how canceling the x's would be sort of like canceling out the 5s? So if this is right, I better get 23/7, correct?
But you're not.
I'm not. 4 times 1 is 4, plus 3 is 7. 1 plus 2, I got 7/3. Right? And so if this is right and that's wrong, this canceling business must be wrong. So listen, I'm gonna give you some broad advice here. You better darn well be sure that you should be canceling if you're going to cancel. It is the number one most misused thing in math. I would be very hesitant to cancel things out. The quadratic formula has nothing to do with this. Oh, you're talking about when we factored then canceled? That was a really important step, right? We talked about that a lot because people just wanted to start canceling everything out. And I said, no, let's factor the GCF out first. And as soon as you did that, we started doing pretty well. So that's kind of that step we need to be super careful with. I'm not saying that it's impossible or we should never do it. You just need to be super careful. Okay, so I want you guys to continue exploring with number 4.
Wait, we didn't make an answer for number 3.
4x plus 3 is the answer.
Oh, the answer that you guys proposed is the answer. The 4x, sorry. 4x plus 3 over x plus 2, that is the answer.
I was right.
There is no more simplifying. You can't cancel anything out there.
Thank you, Davis.
Yeah, nothing else can be done there.
You good work today, Carson.
Okay, number 4. So,
It's okay, Jack. Things happen.
Which one is that?
Jack made a mistake.
This is interesting.
number 4. What do you notice about number 4 that's very different from number 3? What do you see, Max?
There's a Y. There's one common factor. There's a Y. Yeah, there's a Y.
There's a y and
There's 3.
there's 3 of them. There's an x. What do you notice about the denominators?
They're all common.
They are not common. They're all different. Yes. Okay. So this is where what we did for warm-up number 2 will hopefully be very, very helpful. We need to come up with the lowest or least common multiple or the least common denominator for all 3 of these. And I think sometimes it's helpful to consider all the different factors that go into these. So let's look at the different factors. Let's break it down using the factor trees like we've done. What are the prime factors of 5? Isn't it already prime?
Yeah.
Yeah. So I would say 5x is really just 5 times x. How about the 4y? What are the prime factors of 4y?
2 times 2 times Y.
That's right. 2 times 2 times y. And the 3, that's already prime, isn't it?
Yeah.
Okay. So we want all of our denominators to match. They need to be the same denominator, right? It needs to be a common denominator. Yet I've got all these different elements in there. Our common denominator is going to have each of these elements in it. So I'm going to say, I'll just do this off to the side, my lowest or my least common denominator, my LCD. What does it have to have?
Has to have a 5,
It's got to have a 5 and an X
4,
and a 2 and a 2, which is a 4, sure,
a Y,
and a Y.
and a 3.
Whoa, let's simplify that. What is 5 times 4 times 3?
20 something.
60.
60.
20 something.
And of course, X times Y is XY.
Hold up.
So what I did is I basically took each of the elements in my denominators, and just like in number 2, like you multiplied the 8 times the 3 to get the common denominator, I've got a few more of them, but it's the same process. I'm going to multiply each of the unique factors of my denominators together to get my lowest common denominator. That make sense?
Yeah.
Okay. Bless you. Okay. So what I'm going to do is I am going to rewrite my fraction And we're going to make the necessary adjustments to make this work. So it's 9 over 5x minus 1 over 4y plus x over 3. So this can require a little bit of mental math here. So let's focus on the first denominator. My first denominator is 5x, and it's supposed to end up being this, 60xy. What am I missing? What would I need to multiply the 5x by to get that 60xy?
The 4y and the 3.
12.
And 4y times 3 is 12y. There you go.
That's what 4 times 3 is.
Correct. So I would multiply by 12y. And with a fraction, whatever you multiply the denominator by, numerator gets multiplied by the same thing, right? Because we're going to multiply by that smart 1. Now the next one, 4y. How do I turn a 4y into a 60xy? 4 times what is 60? That's right. Times 15, and we need an x, so yep, times 15x. Multiply the numerator by? Same thing, yeah. And how about the last one? The last one is, the numerator is just a 3. How do I get that up to be 60xy?
20xy.
20xy is correct. I will say this is difficult to do if you're in a big hurry. If your goal is to finish it within like 2 minutes, it's going to be really tough. If you take your time and you could use a calculator to do some of these multiplyings, I think you can do it. In fact, I know you can. Okay, so here we go. We know that our denominator is going to be that 60xy.
108y.
12y times 9, Davis, I think you're right, is 108y. Again, we know that this denominator is going to be 60xy. 15x times 1?
15x.
15x, yep. And then that was a plus. Plus, we know our denominator here is 60xy. I don't think so. I don't think it's 20xy.
20x squared y.
20x squared y, yep. Okay. X times x would give you the x squared. Okay. Oops, sorry, Davis. So now we look and we have a common denominator, don't we?
Yeah.
So once you have a common denominator, to get to your final expression, what do you do with your common denominator?
Add them. Or combine them. You leave it.
What do you do with your denominators? You leave it. Right? The denominators stay as is. So this will equal something over
That's what I
60xy.
meant by combine. Like,
Okay.
well, yeah.
I believe you. It's good. All right, and then the numerators. We add and subtract accordingly. Let's look real carefully. These numerators, are there any like terms amongst the numerators? Is anything like the 108y?
No, it isn't. X squared.
Well, but this one has an x squared in there, right? In order to be like terms, they need to have the exact same variables and exact same exponents. So I don't think those two are like. In fact, when you look carefully, you see that none of them are like, right? So my final answer, yeah, would just be one fraction, 108y minus 15x plus 20x squared y, all divided by 60xy. Okay, follow-ups, questions. Michael, earlier, again, you were very vocal. To quote you, I think you said, "I'm confused." Doing better now? I just want to make sure. When you're really vocal, I want to address and make sure that I've helped you out. You're good. Anybody else? Questions? Concerns? All right, well, let's have you guys try a couple of these on your own. Let's try number 5.
With a partner?
Try with a partner. Try on your own. Whatever you think is going to work best for you.
I think what can we do is for
We just got 2 of them here. So number 5. See what you do with number 5. Walking around, I noticed a lot of people had 432 b to the third for their denominator. And I'm going to say, listen, I'm going to say that it's not wrong. It's just not done yet. If you have 432 b to the third, do you all have, is it 3? Kind of depends on what the numerator is going to be. Yeah. you're going to end up with something that you need to reduce. Let me show you the faster way to do this. I'll do it the same way I did before. I'm going to break this down into its prime factors and this down into its prime factors. Isn't 18 really 3 times 3 times 2?
Yes.
Yes.
And b squared is b times b.
Yes.
Yes.
24 is 3 times 2 times 2 times 2, and a b is already a prime factor. So here's how you get your actual least or lowest common denominator in the easiest possible way using your prime factors. Please notice that there are 2 3s and 1 3. So if that's the case, my lowest common denominator is going to have 2 3s. You go with the higher number of numbers, higher number of factors. Check this one out. This one is
There's 2 2s.
a little different. There's 1 2 there, and there's 3 of them there. So how many do you think we'd use?
3.
3 of them. We go with the higher number of factors. So it'd be 2 times 2 times 2. And then with the b's, there's 2 b's and there's 1 b.
You do 2 B's.
So we go with 2 of them. So times b times b. You multiply those out, you end up with 9 times 8, which is 72b squared. So those of you that had 432b cubed, I'm not going to say you're wrong because you're not. You're just going to have to do a lot of reducing in the end. It's going to make it a little more difficult to finish. I'd rather do this on the front end. So check this out. Way to shoot for the, not the moon.
Higher than the moon. I shot for the cloud.
Okay, so let's see if we can do the same kind of thing we did with the previous one. How do I get 18b squared to become 72b squared? Multiply by 4. That's right. So if I go times 4 times 4, sorry?
What, Morgan?
18 times 4 is 72. If you want the 18 to become a 72, you got to multiply it by 4.
Okay.
How do I get the 24b to become 72b squared? Times 3b times 3b. Okay. Those of you that are packing up early, we're not going anywhere. Please don't. So it's 12 over 72b squared minus 3b over 72b squared.
That's 52, not 12.
Oh, 52. Somehow I read 4 times 3. How about 52? There we go. Thank you. It happens.
That's how you get stuff wrong in this concept.
So, once you got a common denominator, what do you do with your denominators?
Keep it.
You keep them the same.
Keep them as is. What do you do with your numerators?
You can't do anything.
You can't really combine them, but you do subtract, right? So it's 52 minus 3b.
Nice.
I didn't say to go anywhere, Peyton, man, I'm sorry. So anyways, it's a little weird how we're having to do this week. Please do not lose your notes packet. We're going to pick these up again next Monday. The rest of our week is going to be project, okay?
How much is the project worth?
16 over 72b squared.
Right now.
Have a good day.
School on Friday.
16. Where are you getting 16
52
from?
minus 36.
It's a 3B. Sorry.
Oh.
The B sort of looks like a 6. It's a 3B.
Thank you.
I'll ask my mom because we're not doing it.